Figure 8.27 multi-purpose sorting program using function pointers. In this example, we're going to introduce a concept called function pointers, which basically allow you to treat a function as data so that you can pass it around a program. And this is a very similar concept to a concept that we'll call function objects, which we'll cover in more detail when we talk about standard template library concepts in C++ Fundamentals Part 2. Now, to give you a sense of how this function pointer concept works, we're going to first take a look at the executing program. Basically, we have a sorting function in this program that allows you to sort into either ascending or descending order. So let's say I type a 1 because I want to sort some values in ascending order. You can see here the original order of the values and then the sorted order of the values as well. So 6 and 4 were out of order, so now you can see 4, 6, and 89, 68, 45, and 37 were out of order, so you can see they're now in order as well. Now if I rerun this program, you can see that when we enter 2, the same set of values is displayed for the original order, but now they are clearly being displayed in descending order in this case. And basically what we did is we created a sorting function that's made more flexible by the fact that it receives as its argument, or as one of its arguments, a comparison function that determines how to compare two values and determine their sorting order. So let's take a look at our function prototypes first, and then we'll take a look at the source code and how we implemented it. So we have our function called selection sort, and I'm not really concerned with the algorithm in this case. I just want to focus on what the function actually does. But it receives as its argument an integer array, and I mentioned earlier in a previous video of this lesson that with arrays as arguments, many programmers will simply represent a one-dimensional array as an asterisk instead of square brackets, so you could see int star here when it's expected that an array of integers will be passed. The second argument is a constant integer representing the size of the array. And here's the most important part in this example. The last argument actually represents a pointer to a function. When you see a declaration in which you have an asterisk inside of parentheses, that indicates a pointer to a function. And in this case, we're going to receive as an argument a pointer to a function that returns a Boolean and takes two integer parameters. So any function that returns a Boolean and takes two integer parameters can be passed into this selection sort function as a piece of data. Now, just like an array name is actually a pointer to the beginning of an array in memory, you can treat a function name as a pointer to the beginning of the function's code, if you will, in memory as well. And you'll see that when we call the selection sort function in a moment. Now we also have a swap function, which is going to take two constant pointers to integers and use them to swap the values at those two locations in the array. And then we have two functions that can be used as the last argument to the selection sort function, one called ascending, which receives two integers and returns a Boolean to determine that two elements should be sorted in ascending order, and then one called descending, which also returns a Boolean and takes two integer arguments and helps us determine that we would like to sort two items in descending order. Now, in our main function, we have a constant integer called array size, which represents the size of the array in the example. We have an integer called order, which will be the 1 or 2 that the user types to help us determine whether we want to sort in ascending or descending order, respectively. And we have an integer called counter, which we'll be using as an array index just to walk our way through the array in a couple of for loops. We also have the integer array called A with array size elements, and we hard-coded an array in this case with elements that are not completely in order. We then prompt for the user to enter whether they want ascending or descending order, and then we display the values in their original order. And then we get to the key part of the program in terms of calling selection sort. This if-else statement, based on whether the order is 1, will call selection sort one of two different ways. In both cases, we'll pass in the name of the array and the size of the array. But in the first case, if the order was 1, we'll pass in the name of the function ascending. In the second case, we'll pass in the name of the function descending. And that is how you actually send a function into another function as a piece of data. You just specify the name of the function. However, whatever that function is must match up with the specified parameter, and that is going to be checked by the compiler. So for example, here is the beginning of the selection sort function definition, and again, when we look at that, you can see that it's going to receive an array of integers, which we're going to call work, a constant integer called size, which represents the number of elements, and something that it calls compare, which is a pointer to a function that returns a Boolean and receives two integer parameters. So in this case, we have to make sure that ascending and descending match up with this parameter, and as we showed you in their prototypes, they do indeed each return a Boolean and take two integer arguments. Now, inside the selection sort function, we implement the algorithm for a selection sort, and the key part of the algorithm here is that we need to be able to compare two values to see if they're out of order or not, and if in fact they are out of order, eventually we're going to be swapping those elements. Now here is the way that you call a function that is specified as a parameter, a function pointer parameter. We dereference the pointer, wrapped in parentheses here. So that moves us from the pointer called compare to the actual function that we're going to call, and that function is going to receive as its argument from the work array the element at position smallest or largest, and from the work array the element with the position number index. And it's going to compare those two values, and if it finds that they're not in the right order, then we're going to assign index to smallest or largest, and we're going to work our way through the whole array to figure out which one needs to be swapped, and at that point, once we get done with that, we will swap two of the elements within the array, passing their addresses into the swap function. Now, you can also call the function, I'm going to just duplicate line 71 here to show you this. You can also call the function without dereferencing the pointer. We could have actually said simply compare with no parentheses around it and use the name of the pointer as if it were a function name. That is also allowed. We explicitly used the dereferencing operator and the parentheses in our original call to emphasize the fact that compare is a pointer to some other function, and there is not actually a function called compare in this program. All right, so you can see here, let me go back to the original code, you can see here that by receiving a pointer to a function as an argument, we can write this function once and be able to sort the values into ascending or descending order based on which function is passed in and whether or not that particular function returns true or false in the condition on line 71. And as far as the functions that we're passing in, their implementations are pretty straightforward. The ascending function takes two integers, and if the first integer is less than the second integer, then they are already in ascending order. So if we were sorting into ascending order and they were not in ascending order, then we would use this assignment statement at line 72. Similarly, descending returns a true or false value based on receiving two values, A and B. If the first one is greater than the second one, then they're already in descending order and will return true. If they're not in descending order, that would indicate that they need to be repositioned to sort the array elements appropriately. So if you do need to pass functions around your program as data, one way to do that is with function pointers, and as I mentioned, we will take a look at a similar concept when we get to the standard template library in the C++ Fundamentals Part 2 live lessons, and in there we'll look at this concept called function objects, which are another way to implement the concept of a function pointer, but in a more object-oriented manner. In the next video, we'll take a look at another example of function pointers, which is an array of function pointers that allow you to do several different things.